than we have been recently. Sorry about that. There we are. What's up, Hacksters? Welcome to Wednesday. I've gotten some comments recently that the audio was very quiet. I've done what I can to fix that, so let me know how the audio levels are now. What we're doing today is a bit of an experiment. So here's the thing. If you only ever show your successes and things that are easy, then you're not going to learn that much. And today I've been suffering a couple of setbacks with this tool, Patra, that I'm using, but I'll tell you the reasons why I'm using it, and then we'll give it another go. So this is a PCB that I'm designing. I'm designing a Wonder Woman tiara with some cool stuff in it. I'm thinking about using this tiara model, but it's designed in Fusion 360 and it's cool, but it has a couple features that I don't think quite match up. It is beautiful and I love that they've given this tutorial, and I think that I can use this rub and buff stuff to give it that metallic sheen that I used in a previous project. Our April Fools from last year, actually. It was really cool. And one cool thing about Fusion 360 as a CAD modeling program for designing 3D prints is that it integrates seamlessly with Eagle from Autodesk, and they both have free trials available. However, I'm more comfortable using an online CAD tool called Onshape, which makes me really happy, and so I don't need the Fusion integration or the Eagle Fusion integration, so I might as well use whatever PCB tool I'm most comfortable with, and I'm trying to get this done on a time budget, on a deadline. So, I've never been amazing at PCB design. It doesn't come naturally to me. I need to keep practicing. So, the two sort of main ones that most people I know use for making PCB art is Eagle and KiCad. There is also like Altium, which is like way more complicated than I'm gonna use anytime in the next few years, but very powerful, also quite expensive. And so like Eagle or KiCad, both great. I've used them before, but I don't want to dig back into learning it. Although there are great tutorials available, including Contextual Electronics' Chris Gamel's Getting to Blinky. I don't want to go through all that right now just to make a quick PCB. So what I'm using is Patchr.io. Similar to Onshape, it's an online CAD tool that runs in your browser, no installing anything. And I'm going to be honest, I've had a little bit of trouble with it today. One thing that I loved about it is that they have, I believe, an integration with Oshpark for producing your PCBs. You can easily export it to use on the Bantam desktop PCB mill that I have, which is great for the tight deadline. I can easily export gerbers that will go into the Bantam mill, and then I'll just easily be able to mill a physical version, so I can have that to test before I send it off to Oshpark and wait a couple weeks for the PCBs to come back. Sorry about the glitching. I don't know why that's happening. Always doing testing and fixing stuff. So, what I've been doing here is I've drawn my little outline, and that's the first thing that happens when you get into the Patchr interface is you just click and drag to create the outline of your board. This one's very simple. It's going to go inside the 3D printed enclosure, so I've made it a little bit smaller. I basically took this Evil Mad Scientist ruler, which I love, which has centimeters on one side and inches on the other, and sketched out roughly where the things would go and how big I thought it would be, just sort of like comparing my forehead with the impeccable Gal Gadot and being like, okay, well, sort of like by the points of the eyebrows and kind of, so like now I have the dimensions. I've thrown those into Patchr in a rough shape that I think will work, and I've put down here, they have surface mount PCBs. Along the right hand side, right here, you can see that there's options for the board, for microcontrollers that you can drop on, including the Tinies, ESP32s, ESP8266s, and a couple of PIC chips. Then you have I/O, including buttons, buzzers, motors, LEDs. Here you have, what size is this? That looks like pretty small. That's a 2mm LED. Interesting. A useful thing in here is that the graph you see, each box is 1mm square, so that helps a lot. Also, when you add something like an LED, it'll also add a resistor, and you can delete that if you don't want it. I don't want resistors because my design by design, uses as few components as possible, and it's quite possible I'm not a professional, like I'm not a professionally trained engineer. I didn't go to school for this, and so far I haven't had a huge amount of problems, just kind of like, you know, these LEDs collectively take more power than will come from the battery in terms of voltage especially. And so I've just been like, welp, I'm not gonna want to order more resistors. I'm just putting LEDs on there. Don't at me. I know it's not the most professional way to do it, but this is gonna be fast. That and yeah, so you have LEDs in both through-hole and surface mount form factor. The surface mount form factor is 1206, and that's exactly the size that I ordered my LEDs in already. So you also have like photoresistors. One other thing I'm going to throw on here is a vibration motor. And like with the LEDs, basically you plunk it down there. If you want to move it around, you click and drag, and then you let go of the mouse and move it around. It's a little confusing. I'm going to put it upside down here because I have a weird system based on what I just did. I'm going to recreate it the exact same way to kind of save time. So I'm going to have a vibration motor in the middle to give you an... you know what? I don't actually need that, do I? I don't need it. Well, I'll keep it anyway. It'll be a multifunction device. Yes! Yes! Timers are great. Oh, then I'll need a microcontroller if I want to do that. Okay, I'm not going to put the vibe motor on there yet. I'm just going to do a little bit of routing, so this is going to be incredibly simple. Actually, you've got 3 sizes of vias. Regular, large, and small. I'm going to grab a couple of regular ones. Come on. Drop them on there. I'm going to put one over here, a little ways in. And the way that I'm designing this is such that I'm going to have a USB cable, and there's going to be the power and ground wires. I'm going to put one on each side of the PCB and then route them around the back of the tiara to a weight in the back, and that'll help hold it in place. To that end, you could use, for example, these coin cell, battery, JST connector, or voltage regulator options, but I'm just going to be soldering wires directly to the board on opposite sides of the board, so none of those will really work for me. But that's fine. It's really easy to do this. I'm just kind of eyeballing to make them be placed in the same spot on opposite sides of the board. So one of these is going to be ground and one of them is going to be power. It's pretty simple to do. I click on one of these options, and what you can't see right now because I'm on top of it. There we go. Oh, actually, the window's too small. Let's get this in frame. Down at the bottom there, you see this new route button, and that's exactly what I'm going to hit, and then I'm going to connect it to this point on the LED. So now that becomes a power pin. Now, the thing with these LEDs is you might not necessarily know what color which thing corresponds to. So you can see how on the left side there, you've got all your components listed, and they'll come up when you click around. So here you've got LED 1206, it says, and it tells you the position and the rotation information. And then also it highlights the text field for whichever pin I've got selected. So if I click this one, it's VCC. If I click this one, it's neg. And I could rename those if I wanted. I'm not gonna. Instead, I'm gonna click on that and do a new route. And so now there's power going all the way through here. And the other thing I'm going to do is connect these two with a new route. And this is, again, something that I'm doing that I'm sure is a little bit wonky, but I'm going to do it this way because I want to. And basically, I'm going to make it so that this can sneak around the back of that via. I probably want to give it a little more space. And, there we go. The other thing I'm going to do is save. There is a hotkey, and I get feedback up there. I could use Command S since I'm on a Mac. What makes me nervous is that I just did a bunch of design and saved that way, and then I somehow got logged out, and I came back, and my entire design was gone. So I don't trust the save, like, hotkey, and I'm making sure that I save frequently, just in case. So I might actually move this via a little bit further in. or just move this part a little further out. There we go. Just put along the edge there to give that a little more space. Okay, cool. So now those power pins are connected. Again, feel free to make fun of my routing abilities. I won't take it personally. I'm doing this in a vaguely aesthetic way, just because I want it to look nice, even though that doesn't really make sense. It's all going to be hidden, and probably I'm cutting it a little too close with some of these traces. So I'm just going to kind of leave it there and route this to that junction as well. And there we have a routed PCB that I think will work with, so we've got basically two sets of two LEDs in series, and those two sets are in parallel. Although there's probably some more resistance in the ones over here due to having that long routing connector. Now, what I could do is put it on the other side of the board. You can edit the top and bottom sides of the board. Here's the bottom layer. It kind of shows you in ghost mode what is on the top. But since I'm going to be milling versions of this on the Bantam, I don't care that much about the resistance being perfect. I care more about being able to mill it all in one go. So I want to keep everything on the top of the board. 'Cause I'm lazy like that. And another thing that I will want to do eventually, probably after I've tested this out, I will want to redesign it in KiCad or in Eagle, just because I want to put some pretty board art on it, and I don't know how to do that in Patra. It may not be an option yet. Let's see. There's silk screens, but I think those are mostly just part names and things. Ooh, if I go to the bottom layer, can I hide the top? Oh, yeah. Nice. See, there are some really nice UI things about this. I think it has a lot of potential. I just wish that the functional things were a little bit more on point, like the ability to drag things around really easily and stuff like that. Yeah, you can align it differently, different layers and stuff. Yeah, all kinds of cool stuff going on here. That is my introduction to Patchr. So now I'm going to go export this as simple as possible. This is an incredibly simple design, hopefully, and I'm going to export it as a gerber for the Bantam Tools PCB mill, which is what I have on this desk next to me. And you could also choose Patchr manufacturing. I'm not gonna. Interesting. Or you could export it as a PNG. Let's see what happens when I do that. Cool. I get save files. And if I drop those into my browser, it may not know that those are PNGs. It doesn't name them copper1.png and copper2.png. It just calls them copper1 and copper2. So, okay, that looks like the top of the board. Cool. And copper2. I guess it doesn't need to give outlines because these are just literally outlines of the copper. Okay, cool. Yeah, and then on the bottom you've got a little plated hole. Cool. So what I'm going to do now is go here and grab... Oh, we're still in this dialogue. That's nice. And grab the zip file with the Gerbers. Oh, look at this. It gives you a little preview of all the different files, including the board outline, the top layer of copper. I'm going to hide myself again so you can see this. Top layer of copper solder mask. Oh yeah, solder mask on top of the copper. Neat. Legend. I wonder if that's silk screen or something. Here's the bottom layer of copper, bottom layer of solder mask, and then the drill, which is those two vias, and that's all. Neat. And I'm going to open this up. Yep, and I've got these Gerber files. I don't quite have time to get this done today, but I'm going to give it a shot tomorrow. And I'm very excited to have a preliminary design for this. I'm going to rework it again once I've made sure that it actually works and put some pretty silk screen on there and stuff like that. But for now, this is solid. All right, thanks for watching. All the links to the tools I mentioned, including this tiara and the design tutorial, as well as Fusion and Eagle and KiCad and getting to Blinky and Patchr, all of these are in, and Onshape, I think. Is that on? I'll make sure that it's in the description to the video. One final thing, there is an crossover code challenge with NXP that's ending soon on March 2nd. Pardon me. And this is designing for a device, the NXP i.MX RT1010, I think. And possibly all of their crossover microcontrollers. The deal with these is that they sort of provide the beefiness of an applications processor with the ease of use and real-time programming, easy updatability, etc. of a microcontroller. You can read more about that on the contest. Just go to Hackster.io/contests. And we've got a bunch of cool stuff going on here. Oh, as always, this is in community contest. It is the crossover code challenge, and you have about 2 weeks left to submit something to there. They've got some ideas there for you. Use the Flex.io as an LCD interface, do motor controlling. Using the PWM, you could write your own PID loops and stuff, use audio examples, build all kinds of... Yeah, motors and audio are basically what this thing is designed for. You could read way more about it on the site. And yeah, check out the prizes. $3,000 gift card. All kinds of cool stuff. Yeah, check it out. Crossover Code Challenge with NXP closing on March 2nd. And check out all the links in the description of this video for the tools that I mentioned here. And hopefully I'll be back tomorrow with an update about the PCB. We'll find out. All right, hack on.